All right, when you go to your Canvas, all right, the Zoom link next week, I don't know if we need to use it or not, but for your back to school night, you know how you have a schedule for back to school night, which if you don't have one, you will get one. And then during fourth period time, which is between, let's just say 5:30 to whatever, then your parent has to click on the Zoom link, and then it will join my classroom for about 15 to 20 minutes, all right? It's not a mandatory. If I see your parents, that's great. If I don't, because most seniors, like I don't know why, but a lot of the parents don't come in because they're used to it already. But its Zoom link is there for them to join during back to school night if they have any questions. Okay. All right. So class resources. Do you see this? You click on this. I think we talked about this before. You go to for chapter 2. Click on that icon or textbook, and then on the very left side we have calculus book, and you click on the arrow till you find your calculus book, which is this one. Today we're working on chapter 2, section 1. Let's say if you have questions about number 21, and then this is how you solve the questions. Do you see that? Okay, I think 21 is part of your homework, either today or tomorrow. Alright, so you do have worked out solutions like this. It doesn't mean for you to start copying down the solution. Remember, we had this conversation about, think about while you're here, right? You want to learn these stuff, right? You try it on your own and make sure you learn it. But along the way, if you get stuck someplace, this is a great resource. You can go back and check to see which part you're missing. Alright, now, if you're having, other issues, then what you can do is, let's go ahead and go to Calc View and open your textbook to page 120, is it 5? Where's our problem? Problem number 1, where is it? Is it page 125 or 127? It is chapter 2, section 1. What page is it? 120? 125. All right, 125. All right, on page 125, you're going to find some red color problems. Which ones are the first red color problems? Can you find it? Which number? Which number is in red? Find the question in red. Isn't it number 7? Yeah. All right, number 7. So if you have questions about number 7, you go to Calc View, and here it is, exercise 7. And then if you view the video, someone will come out and then start working on those questions.
Slope of the graph of a function.
Okay, I think you get the point, right? So you can tell that we have great resources for you to kind of use. So like I said, all of your homework questions are odd problems. So you can either check Calc View or Calc Chat. All right? Okay, we're going to cover our lesson from our textbook. I'm going to go over about 3 examples. This is on page 124. Page 124. Page 124. All right, let's open up to page 124. Take out your notes. All right. At any time, if you're confused, if you want to rewatch the video, make sure you go to your announcement and watch the video again. All right, this is on page 124. This is chapter 2.1. This is called the derivative and tangent line slope. All right, now we have been studying limit, Right? We just finished our first chapter 1 test, which was based on limits. Like there should be a reason why we study limits, right? We don't just study limits because I tell you to study it, but we need to see some application. There's got to be a reason why we study limits, all right? So we're going to apply to something else, the limit idea. We're going to apply our limit idea to find tangent lines. Now, I know that some of you guys are not familiar with the tangent line, so I'm just going to help you to understand it now. Okay, so let me give you an example of tangent line. Here's an example. Okay, we have a function, any function that goes something like this. Okay, this is f of x. It could be any function. Now, in this class, we're going to study different functions. And most of them are very complicated functions. All right? It's no longer just parabolas or lines. We're going to study really complicated functions. Now, along this curve, you have many points. Right? We have a whole bunch of ordered pairs along the curve. All right, depending on where you have your points, you have different tangent lines. So for example, right here, if I take a look at this point here someplace, when I draw my tangent line, it needs to barely touch that location. Just like so, right there. You see it? So this will be your tangent line. That's just one example of tangent line at this location. But we have many, many points along this curve. Do you see the points? If I happen to pick a point down here, can you visualize your tangent line at that point? Can you visualize it? So it will go somewhat like this. This will be your tangent line. And if you happen to pick a point there, can you visualize a tangent line through that point? It will be somewhat like this. Alright, so our goal today is to find the equation. Do you see all these lines? We want to find the equation of the tangent line. Alright, you want to find the equation of the tangent line. So again, this is all review stuff. You should have known this before this class. But just in case, if you don't understand tangent line, I'm trying to explain it to you. And our goal today is to find the equation of those lines. Not everything, but they're going to tell you which one. Sometimes it will be here, sometimes it will be there. They're going to give you an ordered pair. All right, now, how do you find the equation of a line? Do you guys remember? Again, this is a review from integrated 1 and 2, or maybe 3, equation of a line. What do we need to have? What do we need to have for equation of a line? Anybody? You need to have a slope. You know that, right? You need to have a slope, which is m. We also need to have a point, which is x and y. And we need to use one of the equations of the line. There are 3 equations of a line. But I want you to use point slope form. Do you guys remember point slope form? What is point slope form? Y minus y1 is equal to m times x minus x1. Alright, so we need to have a slope, we need to have a point, and we need to use this formula to find the equation of a line. We haven't done any calculus yet. This is all of the stuff that you should have learned from integrated 3 and also from integrated 1 and 2. Are we clear? Do you guys remember all this? Alright. So we're going to use all of these ideas to find the tangent line using calculus. Alright? So today, to find the slope today, which is m, we need to use calculus. So how do we use calculus? What part of calculus we need to use to find the slope? We need to use limits. Alright, because this is calculus, they like to throw in like fancy symbols. But those are just fancy symbols. I don't want you to get confused over some of the notation. So to find the slope, there is a definition. This is on page 125 at the bottom. Okay, it says definition of, do you see it? Definition of tangent line with slope of m. That's your slope. Okay, what does it say? The formula, it says m, which means slope. You guys know that, right? M is equal to limit triangle x. Did you know that this is delta x? Delta x goes to 0. F of c plus delta x minus f of c all over change in x. Again, this notation we haven't seen. They're trying to be fancy. Delta x is same thing as change in x. If you're taking some other science class like physics or chemistry or something like that, they use a symbol a lot. Okay, it means change in x. You don't have to use this symbol. You know, if you don't want to be fancy, you can change the symbol to, I'd like for you to change to h goes to 0, f of x plus h minus f of x all over h. It's the same thing. Does everyone understand why delta x is representing the h right here? Do you see it? And then we used x variables before, so I like to use x, function of x. So I want you to use this formula if you can. And what is this? What is this representing? This is your what? This is your tangent. Not only tangent, it is tangent slope. So basically that would give you your slope. Okay? This whole limit process will find the slope that you need. And you'll realize that tangent slope, which we understand, in calculus, there's a fancy name for tangent slope. What is a fancy name for tangent slope? It is derivative. is just a fancy name in calculus to represent tangent slope. So if you see the word derivative, you think of tangent slope. Does that make sense? Alright, I'll give you a few seconds to finish writing that. Alright, so we're going to do an example with this formula right here. Alright, so I want you to try to remember this formula. Do you see it? Alright, so everyone turn to page 126 and find example 2. Alright, this is page 126, example 2 from your book. It says f of x is x squared plus 1, and you want to find the tangent line part A, where you have a point at 0, 1, and part B, you have a point at -1, 2. Okay, hold on a second, okay, guys?
I'm sorry, is Juan here? Ricardo? Ricardo, I'm trying to read that, I'm sorry.
Ricardo? Yeah.
Can I talk to him for 1 minute?
Alright, so this is example 2. Before we start, I want you to understand what they're asking you. I want you to kind of visualize what's going on. Okay? So don't copy any of this stuff. I want you to just pay attention to me. I'll tell you when to copy this. Can you visualize this function? I hope in this class, all of you guys can visualize x squared plus 1. Can you do that? Okay. Isn't it a parabola? Doesn't it look somewhat like this? 1, 2, 3, 4. 1, 2, 1, 2, 3. And then we're starting at 1, right? And then this parabola is opening up something like this. Don't copy, just pay attention. Alright, do you see this parabola? And then with the red marker, you know we have a whole bunch of points here. It's just invisible, but we have a whole bunch of them along the points. The curves. But we don't want to find a whole bunch of these points. We just want to find 2 of them. Where's the first one? 0, 1 is right here. I'm going to color in red. At that point, at that location, can you visualize your slope, tangent line at that point? What does it look like? Can you visualize a tangent line? Doesn't it look like this, kind of? Isn't that the tangent line? Okay? So we need to find the equation of this line for part A. Alright, again, we don't want to find a whole bunch of points. We just want to find 2 points. First one is there. Where's our second point? -1, 2. -1, 2 is approximately over here, isn't it? -1, 2. Can you visualize a tangent line that goes through this point? Doesn't it go through like this? So for this particular problem, we need to find 2 equations of a line. Does that make sense? So for you to find that, I need to have a slope. I need a slope. I don't know the slope, and I don't know the slope. So how do I find the slope? What formula do I need to use? Yeah. So this is part A. All right, so go ahead and copy this graph. I'll give you about 30 seconds to do that. Okay, when I go over this lesson, I'm going to ask you to just pay attention and not to write and help me along with each step. All right, and then I'll give you extra time later to copy it if you need it. All right, so here we go. You can stop writing. Okay, I'll give you more time later. Just pay attention. Do you remember the formula that we need to use? What is it? Go back to your notes. What's our formula? Limit h goes to 0, f of x plus h minus f of x all over h. That's the formula we're going to use to find. What do we use this to find? Find what? The slope. We need to find the slope, m. We're trying to find m with this formula. Alright, so stay with me. Don't copy it. I need to come up with this first part. I'm going to use a bracket around this. Alright, so don't copy yet. Can someone tell me what f of x plus h is equal to when you have this function? Anybody have an idea? Yeah, what is it?
X squared plus 2x.
Okay, so he says parentheses, pay attention to what he said. It is parentheses, x plus h squared plus 1. Okay, how many of you guys see that? Raise your hand. Okay, so all we're doing is, do you see this parentheses right here? We're going to take this parentheses and we're going to plug it into this x variable. Alright, so you think of x variable to be that parentheses. So is that parentheses squared plus 1. Okay, how many of you guys see it now? Okay, minus, do you see the second part right here? Stay with me, I'll give you time to copy this. What is f of x? It's just x squared plus 1. And then all over, what is it? H, isn't it? H. Okay, so go ahead and copy up to there. I'll give you a little bit of time. Okay, so stay with me again. If you didn't finish copying this, don't worry about it, okay? Just pay attention to me first. Alright, so look at this limit. Can we use direct substitution? We just took an exam on it. Can we take direct substitution? Answer is no. Why not? Because we get a 0 as a denominator. Do you see that? So what does that mean? We need to find other ways. So what other method can we use? Like simplifying method? So remember I told you in this class, in calculus, you should know how to FOIL. Do you see this? X plus h squared means x plus h times x plus h. Isn't that it? Right? So can you FOIL this in your head without showing any step? We should be able to do that. So go ahead and do that. So we have limit h goes to 0. Alright, can someone help me with that? What is x plus h squared? Yeah? X squared plus 2xh plus h squared, and then parentheses, plus 1, and then minus bracket, x squared plus 1 all over h. Alright, go ahead and copy up to there. Alright, remember we're trying to simplify. So we're going to take out all the brackets and parentheses soon, okay? But before you take out brackets and parentheses, do you see this minus? Be careful with this minus. What do we need to do? Make sure you distribute to all of them. Don't forget. If you forget, you're going to get it wrong. You're not going to get a nice answer. So we're going to take out all the brackets and parentheses, and then we're going to distribute this negative to both of them. All right, so stay with me. Help me out with this. We get limit. H goes to 0. I'm taking out everything, so this is x squared plus 2xh plus h squared plus 1. Help me. Minus x squared minus 1 all over h. Very nice. Okay, stay with me, okay? Stay with me. Do you notice anything? You can cancel out which ones? X squared and then negative x squared, and what else? 1 and 1. So what do we have left over? Stay with me, help me. Limit. H goes to 0. What do we have left? Isn't it 2xh plus h squared all over h? Stay with me. All right, stay with me. All right? Okay, so what do you think? Do you notice anything about the top? Do you notice anything? You can factor out an h. You have h in common. So stay with me again. Pay attention. H goes to 0. How do I factor out the h? What do we have? H parentheses. What do we have? 2x plus h all over h. I did all this work. How do I know if I did it correctly or not? Did we do it correctly? How did you know? You can cancel. Remember we talked about this before. It cancels out nicely. Does it cancel out nicely?
Yes.
Then you know you did it correctly. Does that make sense? And so what do you have left over then?
2x plus h.
Limit h goes to 0. 2x plus h. Can we use direct substitution now?
Yes.
So which one is 0?
H.
H is 0. So what do you have left over?
2x.
2x is your tangent slope. Go ahead and copy up to there, okay? You need to learn how to pay attention rather than just copying your notes. There's a difference between paying attention and just copying down whatever, right? It's way better to just pay attention to each step. I'm going to give you about 30 more seconds. Okay, here we go. So again, pay attention to me. Now, this is my answer, but this here, 2x, is representing our slope formula. It's not just your slope, it is your slope formula. This will help me to find all of your slope everywhere around this curve, anywhere. But do I want to find every point along this curve? No, I do not. I want to find which one first, which is part A. What do I want to find first? Point at 0, 1. Stay with me. Don't copy. Just stay with me. So remember, 0, 1 is representing x and y. You understand that? So my slope is not 2x. Even though it says my slope is 2x, it is not 2x. What do I need to plug into there? 0. 2 times 0, which will give you 0. That means you have a slope of 0. Did we already know that? Look at this. Doesn't this look like you have a zero slope? Did you know that horizontal line is a zero slope? If you didn't know, then you should know. Okay? Horizontal line has a zero slope. So it makes sense. However, we still need to find the equation of this line. So how do I find the equation? Point slope. So help me with the point slope. Stay with me. Y minus what? 1. Remember, x, y is your x1 and y1. Did you know? Is equal to, help me, 0 times x minus 0. But what is 0 times anything? 0. So what is this? Y minus 1 is equal to 0. So your equation is what? Y is equal to 1. Isn't that a horizontal line? This is a horizontal line at what? 1. So does it look like you have a horizontal line at 1? So there it is. So that's your tangent line. We found one of them. All right, so go ahead and copy part A. All right, let's go to part B now. If you haven't finished, it's okay. All right, I'll give you more time later. All right, part B. We want to find different slope at a different point. Do you remember which point we need to use for part B? -1, comma 2. We need to find the slope. Okay, so since we need to find the slope, do I go through this long process over again? No, heck no. We're not going to go through that again, right? Because we just need to use which part? This one. We just need to use that one, slope formula, which is 2x. But this time, what number are you going to plug into x? So this is 2 times -1. So what is your slope then? -2. So you have a point, and your slope is -2. We found it. So we have a point at -2. This is x1 and y1. Can you find the equation of the line? All right, go ahead and you find the equation of the line. Okay, so help me. What is it? Y minus 2 is equal to -2 times x plus 1. You guys need to help me. If you can help me, that means you understand the lesson, right? So that's why I'm telling you to stop writing and just pay attention to me. And what do? Can I distribute? All right, so y minus 2 is equal to -2x minus 2. And then which one do you move over? Plus 2 and plus 2. So what is your equation? Y is equal to -2x is the equation of the other tangent line. All right, so I'll give you time to copy that. Okay, how many of you guys were able to follow the lesson today? Raise your hand. Okay, so that's all we are doing today. Okay, but I do need to go over other examples. All right, now I want you to take out your graphing calculator. Go ahead and take out your graphing calculator. I told you to have your graphing calculator, right? Alright, so here's my graphing calculator. Alright, so go to y equal to, okay, what was our function? Do you remember our function? Help me, what was our function? X squared plus 1. Okay, what was our first tangent line? Y is equal to 1. What was our second tangent line? Y is equal to negative 2x. You see it? Go ahead and graph. Boom. And boom. There it is. We have two tangent lines at the location that they're asking you to find. So we use limits to find tangent lines along the curve. Now you're asking, why do we need to find the tangent line? Did you know that finding a tangent line is really important in physics? It is. We'll talk about all those things later on. I mean, calculus is like a basis for everything that happens in this world. You know how Newton said, "Oh my God, I know it. I know." And when the apple fell in on his head, he goes, "Oh my God, I got this." It's because he understood calculus, okay, and everything made sense. But we need to know the basics first, okay? So I'm going to go on to the next example, but anybody need more time with this? All right, so let's turn it over to page 127. On the very top, you're going to find something. It says definition. Do you see it? What does it say on page 127 on the very top? What definition do you find? It says definition of derivative. All right, let's go ahead and copy the definition derivative. What is it? It is f prime of x is just the notation. Do you see it? It's just the notation. We're going to use this notation for derivative, okay? Again, calculus is trying to be fancy. Don't be overwhelmed with notation. So f prime just means first derivative is equal to limit change in x goes to 0, f of x plus change in x minus f of x over change in x. Doesn't that look very familiar?
Yes.
That is exactly the same thing as what? It's the same thing as a tangent slope. Slope of a tangent line. Like you said, it's exactly the same thing. So do I need to use this notation? No. What notation can I use for derivative? Limit h goes to 0, f of x plus h minus f of x all over h is your derivative and your tangent slope. It's the same thing. But guess what they're going to do in your book? One of the direction they're going to ask you to find the derivative. And the other direction they're going to ask you to find tangent slope. Are we doing anything different? No, we're not doing anything different. We're doing exactly the same thing. However, the problems that we're going to work on are a lot harder. Now, example 2, this one was one of the easiest one. This was one of the easiest one. Why? Because this is simple. It's just x squared plus 1. It's very simple. You can have fractions, which is complex fraction. Very difficult. You can have radicals, square root, which is very difficult. Does that make sense? So we're going to take a look at one of your questions, number 21 on page 131. Okay, on page 131, number 21, which is part of your homework. Read the direction. what do they want you to find? It says find the derivative of f of x is equal to 1 over x minus 1. Alright, so derivative is what formula? Have you memorized it yet? Limit h goes to 0, f of x plus h minus f of x all over h. Can you memorize this by end of today? Sure, you can do it. Okay, so stay with me now, okay? Don't copy anything, stay with me. Can someone tell me how to find our first bracket, which is f of x plus h? Do you know that? Say it out loud, I can't hear you. 1 divided by x plus h minus 1 and close a bracket. Okay, how many of you guys see that? That's hard to see. Stay with me again. What's the second bracket right there? What's the second bracket? Minus bracket 1 over x minus 1. And then all over h. Do you see what I just did with this parentheses right here? All I did was just replace this with that parentheses. So it's parentheses x plus h minus 1. You see that? All right, so go ahead and copy this. But this one is very difficult. Doesn't it look very complicated? It does to me, right? But we did this for part of your test, didn't we? How do we simplify those two fractions on the top? How do we simplify that? Because we can't use direct substitution. So what can we do? What do I need to multiply each one by? Common denominator. So I need to multiply this one by x minus 1. X minus 1. I multiply the other side by x plus h minus 1 and x plus h minus 1. Do not multiply anything. So stay with me. So this is limit h goes to 0. First one is x minus 1 times 1 all over x minus 1 times x plus h minus 1 minus, just stay with me, okay? And top is x plus h minus 1. Bottom is x minus 1 times x plus h minus 1 all over h. All right, go ahead and copy that. Look at how ugly this thing looks. But you don't give up on this. You need to practice. This is what we're supposed to cover from Integrated 3. You just haven't had enough practice, which is okay. We're going to practice during our class. So basically, this is kind of like Integrated 3 / calculus. That's awesome. Someone needs to pay me double. All right, so here it is. Again, stay with me. All right, stay with me, guys. Do you see this negative? It's really important to do what with that negative? Distribute to all of them, right? So stay with me and help me. I'll give you time. I'm going to take out all the parentheses, okay? So if I take out the parentheses, I have x minus 1, and what else? Minus x minus h plus 1 over x minus 1 times x plus h minus 1 all over h. There it is. Hold on, stay with me. Look at this. Do you notice anything on the very top? X will cancel out with negative x. And what else? 1 will cancel out with 1, a positive 1, right? So what do we have left over then? limit h goes to 0, negative h over, help me, x minus 1 times x plus h minus 1 all over h. Stay with me. Do you remember what to do with this fraction over a fraction? Do you see this h? I can write h as what? Do you remember? H over 1. What do you do with that fraction over a fraction? You take this and multiply by the reciprocal. Okay, what happens if you multiply this one by reciprocal? H cancels out. So do you think we did it correctly? Yes, because it cancels out. Isn't this very similar to what we've been doing up to this point? Right? That's why we've been practicing limits, so we can do this. All right, so copy up to there, and we'll continue. And when you're writing, you should kind of do it on your own. Like, you shouldn't even look up. You should know the steps. These are just algebraic steps. Does that make sense? These are skills that you needed to develop during integrated 3. So I want you to practice developing your skills during the note time. All right? All right. Okay, I know some of you guys aren't done, but stay with me. Look, h's will cancel out. 2h will cancel out. So we have negative 1, right? Because h and h cancel out. Negative 1 over x minus 1 times x plus h minus 1. Can we use direct substitution? All right, what is it if you use direct substitution? We get x minus 1 times, this is 0, so this is x minus 1. So what is x minus 1 times x minus 1? Negative 1 over x minus 1 squared, and this is your answer. What is this representing? Hold on, what is this representing? That's your slope formula. And this will be used to find other tangent slopes. Go back to your direction. Do I need to plug in any values? No, why not? Because they don't give you any points. But if they give you different points, how do I use this? Plug in the x value to find the slope. Does that make sense? But this one, we're done. What is another fancy word for slope formula? Derivative. So they're asking you to find the derivative, which is that, and we're done. All right, so go ahead and copy up to there. And we are done with our lesson. Perfect timing. And I'll